Okay, everyone. Happy Monday. You made it through another weekend being in school dismissal. So here we are on lesson 17, complex sprite movement. So we're just going to dive right into the lesson here on code.org. Overview. The class learns to combine the velocity properties of sprites with the counter pattern to create more complex sprite movement, such as simulating gravity, making a sprite jump, and allowing a sprite to float to the left or the right. In the final levels, the class combine these movements to animate and control a single sprite and build a simple game in which a character flies around and collects coins. So we're continuing to use our skills to be able to make these simple games. Hopefully, as you're continuing to build your kind of tool set, you're once again starting to get an idea as to what you'd like to do for your game. That will be done in the final lesson, which is going to be 23, I believe. So we still got a few more lessons and a few more skills to get through before we get to that point. So let's look at this here. Velocity and the counter pattern. So this is, once again, you're supposed to predict, which obviously I've already done, so it's going to be hard for you to do this on your own. Using the counter pattern with a sprite's X and Y property makes the sprite move smoothly across the screen. In this program, the counter pattern is being used with the sprite.velocityX property instead. And so what we're doing now is we are increasing the velocity as we go through the program. So what do you think will happen when the code is run? Why? And once you're ready, you can run the code to find out. So you have to type in a response here. I've already typed it in. I can't reset it, unfortunately, once it's been done. But what we're doing, as I said, is we are increasing the speed. So when we do the sprite.x equals sprite.x plus 1, we're increasing the movement of the sprite across the screen. And so it's going to just uniformly move across the screen. But when we already have set a velocity and we're increasing that velocity on a regular basis, this is what's called acceleration. And so it's just going to continue to go faster and faster across the screen as it goes through. So you can look and see here, instead of moving in a smooth, fluid motion, it's going to start off slow, and then it's going to speed up and just keep going faster and faster as it goes off the screen there. So this is called acceleration as opposed to just a regular flat speed. And that's what we're going to be looking at with and experimenting with throughout this lesson here is, as it said in the beginning, we're using complex sprite movements. We're using the counter pattern in conjunction with a velocity to be able to see that acceleration. So, velocity and the counter pattern. As you just saw, using a sprite.velocityX property with the counter pattern will change a sprite's velocity during the program. This makes the sprite speed up. Do a little practice using this pattern yourself. So let's go back to the original version here. This program already makes a car move across the screen, but it's going very slowly. Use the counter pattern with the sprite's velocity X property to make the car speed up. Okay? So this car is just going really slow across the screen. So if you remember, in these past few lessons, I've been trying to teach you and help you understand that when you're setting up the program, all of the stuff in the beginning of the program, before the draw loop starts, that's where you set up all of your variables. So you're going to declare the sprites, you're going to set their animations, you do all of that outside of the draw loop. And then once we're in the draw loop, that's when we're able to manipulate the characteristics of the sprite that we want to change. In this case, we want to change the velocity of this car to increase as it goes across the screen, which is what we're doing. We're using the counter pattern to increase the velocity. So, to do that, we need to add. So, if we're going to do that, we're going to have a variable equal itself. So, we're going to update the sprites here. And then we need a plus little thing here, for those of you who like using blocks for everything instead of just typing. Okay, and so this is going to be our car velocity x. So we can take the car.velocity x and put it in there, because we want the velocity to be increasing. And so we need to set it equal to itself and add something to it. So we'll put car.velocity x equals car.velocity x. And then if we want a gradual increase, then we're going to make it increase by, like, say, 0.1. If we want it to accelerate really quickly, then we're going to do, like, 1 or 1.5 or even 2. So we're just going to start with 0.1 and kind of see what that does and how that kind of pans out. So you can see, if you remember before, it was really just inching across the screen, but now it's picking up speed as it goes across. And so then we can make this, say, like 0.5, and you can see the acceleration is going to be even quicker. Okay, so notice this, the speed that it's moving is not ever a uniform speed because it's constantly increasing. We are adding some to the speed each time. This is much different than the counter pattern where we added to the position each time. And so the speed was uniform. It moved at the same rate all the way across. But now what we're doing is we're increasing the rate in which it's moving. So that at any given point, the speed is going to be increasing as it goes across the screen. So this is, of course, the first part of this lesson. Hopefully, if you looked at this and you watched this video, you're like, yeah, I got it twinding, and you can continue on and everything's fine. If you're kind of just like, what in the world just happened? Watch the video again, see if you can follow along, and make sure you're understanding what blocks I'm putting in and what's going on. And then, as we go through the rest of the lesson, if you need additional helps, I will be creating videos for additional parts. I won't be doing for every single puzzle. There are, in fact, we have 14 of them this time, but I'm probably going to be doing every few puzzles to help you out and to make sure you're understanding what's going on. So hopefully you're getting this. You had a great weekend, and time to dive right back into a wonderful day of creative coding.